It is my honor to introduce my work, Decoupling Static and Hierarchical Motion Perception for Referring Video Segmentation. This is a joint work by Nanyang Technological University and Fudan University. First, let me introduce what is referring video object segmentation. Referring video object segmentation, also known as language-guided video segmentation, aims to ground and segment the target object referred by a sentence within a video. As shown in the figure, giving the language query expression like, "the cat playing with the teaser," video segmentation model processes the language and videos together and then outputs the segmentation mask for the referred object. Current approaches in referring video segmentation typically oversimplify the complex nature of language by reducing it to a single sentence embedding. This approach tends to overshadow the distinct importance and unique static or motion cues offered by the sentence. For instance, consider the sentences, "The little girl in red, standing near the chair and drinking," and "The little girl in red, moving near the chair and drinking." These two sentences share 10 out of 11 words, leading to highly similar sentence embeddings, despite potentially referring to different targets. On the other hand, the precise capture and alignment of motions across the temporal domain is a challenging issue. The motion cues provided by expressions may span a variable number of frames. For example, there are brief actions that occur over a few frames, like flying away, as well as long-term actions that persist throughout the entire video, such as, "walking from leftmost to rightmost." The unpredictability of the number of frames in which these actions occur greatly intensifies the challenge and complexity of capturing and comprehending motion. To solve the above challenge, we propose our approach DSHMP. First, we propose a text decoupling module to make static cues and motion cues perform their distinct role, alleviating the issue of sentence embeddings overlooking motion cues. Second, we design a hierarchical motion perception module that effectively processes temporal motions, enabling the capture of motion patterns spanning various frame intervals. So what's text decoupling? It aims to decouple image-level segmentation and temporal-level motion understanding. As shown in figure, we let the given sentence focus on two distinct components, static and motion. In this way, static cues and motion cues perform their distinct and complementary roles, enhancing the comprehensive understanding of the referring expressions and videos. Next, we propose a hierarchical motion perception module to gradually comprehend temporal information based on object tokens, starting from short-term actions and progressing toward long-term actions. Hungarian matching algorithm is first employed to match adjacent frames considered as the tracking result with noise. Then, motion information and frame token with the same track are fed into hierarchical cross-attention mechanism to calculate motion correlation. Subsequently, we engage in token merging to accumulate short-term motion information and create merged tokens for higher-level understanding within the hierarchical framework. The merging operation reduces redundant tokens and enhances those associated with motion cues. This module mimics the way humans understand videos by processing short clips and building an understanding of long-term concepts based on the recollection of short-term clips. DSHMP achieves the state-of-the-art performance on the newly released motion expression video segmentation dataset MIVIS, with a significant improvement of 9.2% over the previous methods. Besides, our DSHMP maintains state-of-the-art performance on Ref YouTube VOS, Ref Davis 17, A2D sentences, and JHMDB sentences, underscoring its generalizability and effectiveness. The qualitative results further show the effectiveness of our DSHMP that can capture temporal information effectively across varying timescales. Thank you for your listening. Our source code and model are released on the GitHub.